Okay, we're on. Today is Friday, 15th of November, year of our Lord 2019. We are going over review quiz number 2 on page 211. Here is your answers. Brett, number 1, greater than, less than, or equal to? Equal. Anybody not understand, you can create an equivalent fraction by multiplying the numerator and the denominator by the same number, right? Can anybody tell me how else you could have determined those two to be equal? Other than multiplying the numerator and denominator by the same number, can you tell me another way you could have figured out those were equal? There's actually 2 other ways. Rachel? You could have given them the same name. You could have either reduced 6/15 and it would have been down to 2/5, or you could have made 2/5 15ths. But there's another way. Think. Raise your hand. Spence. You could have cross multiplied. What's 6 times 5?
30.
What's 2 times 15?
30.
Okay. Number 2. Greater than, less than, or equal to? Rachel.
5 and 6 is greater than 4.
Greater than. One way to determine that 5/6 is greater than 4/9 is to use good old-fashioned math sense and to look at it and say 5/6 is almost the whole pizza. 6 pieces, I ate 5 of them, the whole thing's almost gone. 9 pieces, I only ate 4, not even half of it's gone. You could have used just good old-fashioned math sense, or you could have been diligent like Cameron and thought, you know what, I'm supposed to give these the same name. So you could have turned them both into 18ths and got 8/18ths compared to 15/18ths. Number 3, greater than, less than, or equal to, I'm not calling Rachel again. David. Greater than 5/9. Now, if you tried to use good old-fashioned math sense, this one wouldn't have been as easy because it's not as clear as the one before that. So if you give them the same name, you turn them both into 45ths. And you're comparing 27 45ths to 25 45ths. See, it was close. 27 45ths is greater. Number 4, Ethan.
I had that they're equal.
He had that they were equal. Did you all get that they were equal?
Yeah.
I bet none of you found out they were equal by multiplying 35 times 24 and 40 times 21. Did you really? All right. Anybody else use a different strategy? What was your strategy? Yeah.
Common sense.
Common sense?
Yeah.
How does common sense work there?
Reduce. Well,
Listen.
it's 5 away from here, and it's 4 away from here, and it's like smaller. So therefore, it's.
Oh, Noah, no, bud. No, listen. Noah, big difference between, look at number 2, Noah. Number 2, 5 out of 6 compared to 4 out of 9. That's good old-fashioned math sense. But what you just gave me was pure guess. You just said 35 and 40 are 5 apart, and 21 and 24 are 4 apart, which are actually only 3. And from that, you're like, oh, okay, I guess they're equal. No. You could have cross-multiplied or given them the same name. How'd you give them the same name, Elise? She went to 120 for the lowest common multiple and ended up with 105 over 120 and 105 over 120. You could have reduced those as well, right? And got 7/8 in both. How did you order number 5, Noel?
5 12ths, 1/2, 2/3, and 5/6.
5 12ths, 1/2, 2/3, and 5/6. Number 6, Micah, how'd you put those in order?
5 4s, 1, 5 14ths, 1 4/7, and 1 5/8.
5/4, 1 and 5/14, 1 and 4/7, 1 and 5/8. numbers 7, 8, 9, and 10 were, I think, simpler examples of what you do when you multiply like bases, what you do with the exponents, and when you divide like bases. B squared times b to the fourth is b to the seventh.
6.
C to the fifth times c to the negative 2 is, Brett, c to the third, c cubed. A to the seventh divided by a squared, David. A to the fifth, and number 10, n to the negative 2 divided by n cubed. Jordan? We got n to the negative 2 divided by, is it n to the third?
Yeah.
Okay. This fraction bar is a division sign. So it's negative 2 minus 3. Negative 2 minus 3. Listen, here's my go-to. What do I always say? When you're a little bit confused about the signs, go to the temperature thing. If you've got minus 2 and you're subtracting 3, what's the temperature going to be? You're going down 3 from minus 2. No, it's negative 2 already, and the temperature is getting colder. It's going negative 5. So if this is n to the negative 5, what do you do when you have a negative exponent? Remember this simple little thing, David? Whoop. When you got a negative exponent, you simply, this seemed to work when I did it, so I'm going to stay with it. Put it in the denominator as positive under 1. Way to go. And number 11. What is your scientific notation for the people that, or the pounds of popcorn eaten? We found out that, who was it that had their fair share? Ella has her fair share, we contributing, and Jordan. Who else said they ate a lot of popcorn? Schmeiss.
I ate popcorn yesterday. I ate a lot of popcorn.
Did you get 1.12?
Yeah.
Did we already do this yesterday?
No.
Times 10 to the 9th.
I have a question.
Yeah. Listen up.
I thought for n, I got it right, but n minus, I thought you like take the highest, like you take 3 minus 2 and go with 3, and it's like positive, so it'd be n.
You're not listening, because I think someone else in the room did the same thing. You looked at a negative and a positive, and you thought, okay, I'll go to my rules. 1, because 3 compared to negative 2, signs are different. Find the difference, right? But that's not the rule for this. It's negative 2 minus 3, which is, remember the rules? You don't actually subtract,
So yeah.
you add the opposite. Does that make sense?
Mm-hmm.
So I see what you were thinking, Kira. Signs are different, find the difference, use the sign of the larger, but when you're subtracting, you actually change it to addition.
I got it right, but like,
All right.
it's never really.
Here you go, ready? You'll have no homework if we can successfully answers 1 through 8 together, and then you'll get to work on 9. Ready? Number 1, page 212. What's the difference between the greatest common factor and the least common multiple? David.
Greatest common factor is the largest number that does the most numbers,
Okay.
and the least common multiple is the smallest numbers that both
Yeah.
things.
Pretty clear, right? The greatest common factor is the largest number that's a factor of both numbers, and you use it to reduce fractions. The least common multiple is the smallest number that's a multiple of both, and you use it to create an equivalent fraction, especially when trying to find common denominators. Number 2, 3 examples of prime numbers greater than 20. Give me 3 prime numbers greater than 20. Seth. 23.
31.
31.
37.
37. Very good. Number 3. 3 examples of a monomial. Elise. How did she know I was going to call on her? Just give me an example of a monomial. 2a. There you go. That's a monomial.
Oh.
It's got 2 elements to it. It's got a coefficient and a variable. Give me another one. David.
7b.
Okay, give me something besides just a coefficient and a variable. John.
6b to the third.
Okay, 6b to the third. It's called a monomial because they're written as one thing. Even though there's a coefficient and a variable and it's raised to a power, one thing. That's a monomial.
Oh.
If it was this, listen, if you're wondering, okay, so if it was written like this, if it was 6 plus b cubed, is that a monomial? No. This is 2 different terms that you would add together. This, since they're all multiplied together, is essentially one term. Mono means one. You learned that somewhere along the line, right?
Yeah.
Next. Number 4. What's it mean for 2 numbers to be relatively prime or prime to each other? Dom.
That no factor can go into both of them.
Other than 1. Number 5. A fraction is in blank if its numerator and denominator have a GCF of 1. If it's a fraction and the greatest common factor is 1, that means that fraction is, it's in, no, that means the fraction is in simplest form or lowest terms. Listen, these are the types of questions, and it never fails. 5th graders were sailing along in a lesson, they get it all, and then you get one of those tests or quiz that asks you questions about it, and they get them wrong. Like if I gave them 100 problems to reduce, they would do them all right. And then here's the question on the test. Ready? You reduce fractions by dividing numerator and denominator by the greatest common factor, and they put false. They've been doing it for a week and they can do them all right. But when they see it in writing, they don't understand it. It's important to understand it. Next. A blank is a whole number that has positive factors other than 1 in itself. In other words, it's the opposite of a prime number. It's the opposite of a prime number, yeah. No, relatively prime means 2 numbers that only share 1 as their common factor. Yeah. What's that big word that's opposite of a prime number? Spence. Composite. Number 7. When you write numbers as the product of prime numbers, how are you writing them? When we did the GCF and the LCM, we did prime factorization. And number 8, 2 fractions are blank if they represent the same number. They're equivalent. Your job is to do 9 through 30. We'll go over 9 through 30 on Monday, and then we'll finish the chapter review. Test is when. Who asked me that when they came in? Who asked me about Rachel? Test is when, Rachel? Tuesday.
I'll write it down for you so you don't have to do
December 13th. That's like 4 weeks from today.
So get to miss school for how
Nice. And then you'll have Then you have 1 full week.
Yeah, but my recovery.
You can pick up the-
I can't go to volleyball because my recovery is because
How many days?
2
2 weeks? What is that? What are you doing?
Oh, that looks really
Oh.
bad. I was just thinking you gotta fix that.
Whatever, Isaac. You're watching too many of those,
Mr. Frankie, 9.
too many of those older movies.
Yeah, so I'll go on Friday morning to Miami. I'll sleep
I would cry at that
Rachel.
Oh, I already did that. I'm on 13.
So like a tree.
That's just my bad.
I don't want to sit
That's like,
Hey, cut! If one person has a question, they're probably not the only one. In case you forgot, and by the way, you have to be able to do this for 2 sections of the test, GCF and LCM. You need to be able to take a number, and I'm going to do it this way this time instead of the tree. And you have to be able to break it down into its prime factors. If you want to see that in tree form, Noah. So you've got a 2, both ways, Noah, see here? 2 and 3 threes. Same thing as there, right? So if you wanted to find, if you had another number to work with 54, and you wanted to find the greatest common factor, you would find the common factors between the two and use as many as there are common. If you wanted to find the least common multiple, you wouldn't worry about what this one had in common with the other. You would use every factor to its highest power. $13? All right, here's 13.
You got 8 from the
First thing is you do the prime, Cam, number 13, you do the prime factors of 19. Well, how convenient. That was easy because the prime factors of 19 is prime. So it's 19 times A times A times B because you have A squared. That's it.
Oh, thank you. I forgot how to do that.
Make sure you keep working because if you have any troubles on 17 through 22, you need to know. Kim, are you going to the Springfield game tonight?
No.
No?
Really?
I just lost the name. Trimble, Gloucester Trimble. But I think it's all the way down to St. Clairsville.
Oh, is that like the championship or something?
No. Yes. 22? Whoa. 54. That's
Wow.
14.
That's the week. I can't do 22. I'm good. Actually, I was doing my report.
Hold on. We're going 22. That was the first question.
How are you on
Ladies and gentlemen, number 22. In order to find the greatest common factor, we've got to do the prime factorization. So, first thing I'm going to do is concentrate on my 54 and 164, right? And by the way, that's the hardest part because the letters are easy. The variables are easy. It's going to be S times S times S times S times T times T times T times T, right? All right, so we're going to do 54. What do you want to start with? Can't start with 8 because 8's not a factor of 54. 6. 6 times 9. 2 times 3. 3 times 3. What do you want to start with? Could start with 2 if you want. 2 times. What gives you 164? 2 times what? 82. Do 2 again. 41. Okay, we're looking for greatest common factor. What's my job once I get them prime factored? To find the, first find common, right? So what's in common here? It's only the 2. Is that possible?
Yeah.
2 big numbers, and is it possible that the greatest common factor would be 2?
Yeah.
Yeah, possible, is it?
Yeah.
Okay. I mean, if you're unsure of yourself, check it. Say, man, is 4? No. 8? No. Okay. So if my greatest common factor is 2, how do I? So it'd be 2. I have S to the 4th and just an S. How many S's do they share in common? Just 1. I have T to the 4th and T cubed. How many T's do they share in common? 3. 2ST cubed.
We do number 8.
Didn't you just ask for 17 before?
I mean 17.
Yes. 17, then 13. Well, 13 I already did. It's right here. Because 19 was prime, it's just 19. The prime factors of 19 are 19 and 1, so
Oh, so we should reduce it on that one, right? Like, or we should not reduce it.
A squared is A times A
Yeah.
in its smallest parts.
Alright.
Okay, which one do you want me to do, Kiara? 17 or 18?
17. What?
17.
I forget how to do that. He just did 22. I think I have the right answer.
Is Dina scolding you?
Hey,
20, 40, 90.
That's
Not.
No, hold up. You're doing the classic confusing factors and multiples. By you saying 180 is telling me that you're looking for the common multiple. 17 through 22 is asking for the greatest common factor. So it's going to be smaller. Yes. Kiara, first I want to appeal to your math sense. Without even doing the prime factorization, what's the largest number that's going to go into all of these?
10.
See, you know that, right?
Yeah.
Now, if you want to prove it to yourself by doing the prime factors, Kara, if I had three numbers and I did the prime factors, I already know it's going to be 10. But I've got 225, 2225, 2335. To find greatest common factors, the threes are out because they're not shared. I have a 2 here and a 5 here. I got a 2 here and a 5 there. So what do they share? A 2 and a 5. What do they share? A 2 and a 5. 2 times 5 is 10. Again, test is Tuesday. If you still have questions, make sure you ask before you leave today. Monday, we come in, go over these, and then finish with the rest of 213 and kind of like a preview of the test on Tuesday.
I think reducing, I don't like it.